There is something called a mole in chemistry. Yes. It's a wonderful thing that we're going to spend a whole lot of time on in the future. One of our most important units.
Is it hard?
Is moles hard? I mean, it's a lot of math. Yes, it is 6.022 times 10 to the 23rd particles or atoms of an element or compound. It is. Nice job, man. It is going to be a lot of math and a lot of conversions. I wouldn't say it's hard or any, but I wouldn't say it's easy. How are we doing, ladies and gentlemen?
Okay.
All right. Not too bad, hopefully. Hopefully we're doing pretty well. Today, what we're going to do is we are going to go over our formative. I think it was actually last week. So finally going over that formative on drawing ionic and covalent compounds. And then what we're going to do is we are going to talk about naming again, and because we're going to do a practice sheet that has ionic and covalent naming before your formative on naming compounds tomorrow. So if we open up that formative from last week, it should look something like this. Either you have it up or you're looking at the screen. So it should look something like this, where we have 4 things where we first had to identify ionic or covalent. So if I refresh my memory or you refresh my memory on ionic versus covalent, can you guys remind me how to identify the difference between ionic and covalent compounds?
Well, ionic,
Non-metal and metal.
All right.
an ionic reaction is valence electrons are removed or taken.
Perfect. Okay. So we have non-metal and a metal, and then electrons are removed or transferred. All right. And then covalent, what kind of elements do we have and what happens to our electrons?
Both non-metals and they're shared.
All right. We have 2 nonmetals in covalent and our electrons get shared. All right. So I just wanted to refresh us before we get started on that, because we are going to have to know both those things, especially on our summative on Friday. So ionic and covalent. So let's go through first and let's identify, is this an ionic or covalent compound? So is this a metal or a non-metal here?
Non-metal.
It's a non-metal. And what about hydrogen? Is that a metal or a non-metal?
Metal,
It is what?
non-metal.
A non-metal. Perfect. Non-metal. So we have 2 nonmetals. So 2 nonmetals combined, is that ionic or is that covalent again?
That's covalent.
That's covalent. Perfect. All right. What about the next one? We have aluminum. Is that a metal or a non-metal?
Metal.
That's a metal. Chlorine, is that a metal or a non-metal?
Non-metal.
Non-metal. So if we have a metal and a non-metal, is that ionic or covalent?
Ionic.
Ionic. What about lithium? Metal or non-metal?
Metal.
Metal. Bromine, metal or non-metal?
Non-metal.
Non-metal. So is that ionic or covalent?
Covalent.
Ionic.
Ionic. Perfect. Metal, non-metal makes ionic. Carbon, metal or non-metal?
Non-metal.
Non-metal.
Non-metal. Fluorine, metal or non-metal?
Non-metal.
Non-metal. So fluorine, 2 non-metals makes a
Covalent.
covalent bond. Perfect. All right. Any questions so far? An identification of ionic or covalent? All right, so then we're gonna have to draw those Lewis dot structures. So we have to worry about the sharing and transferring of electrons. So let's first draw the Lewis dot structures. We have nitrogen, which has 5 valence electrons, and we have 3 hydrogens on this one. So we have 3 H's, and each one has 1 valence electron. Now remind me, for a covalent compound, what happens to our electrons?
They're shared.
They're shared. So we have to show that those are being shared by circling the 2 electrons together, circling 2 electrons being shared together, and circling 2 electrons that are going to be shared together. Does anybody remember what we changed? That circle with the 2 valence electrons being shared, what do we show to represent that?
The line.
A line or a dash. So we have nitrogen, and it's got 3 hydrogens sharing electrons between those 3 hydrogens. Do we need to bring anything else over for that
The
Lewis dot
two.
structure?
2 other electrons.
Perfect. We got to bring that pair of electrons back over to make sure that nitrogen has its 8 that are being shared, and hydrogens each have 2 that they're being shared. Are there any questions on this Lewis dot structure for nitrogen and hydrogen? All right. And then we have our next one, aluminum and chlorine. So let's draw our Lewis dot structures for aluminum and chlorine. And can you remind me what happens to the electrons on ionic compounds?
They get shared to the chlorine.
They get shared?
It transferred.
Transferred. So ionic transfers their electrons to the chlorine. So how many valence electrons does chlorine want to have?
8.
It wants 8. So how many does it need to gain in order to have 8?
1.
It's 1.
It just needs to gain 1. So aluminum is going to give 1 valence electron to chlorine. And then it'll give a second valence electron to that second chlorine, and a third valence electron to the last chlorine. That way each chlorine has 8 valence electrons, and we've gotten rid of all the valence electrons on aluminum. That way its inner shell, so its second most shell, is now its outer shell, and it has 8 valence electrons. So all of our elements have 8 valence electrons, but we are not done because we have to write this in ion form. How do we write this in ion form?
Do the formula.
I will give you not the formula. So the formula was already given to us way over here, but I want to write this in ion form. So I want to create ions here. So how do I create aluminum as an ion?
We had a +3 above it.
Add a +3, showing that it gave away 3 electrons. And then chlorine, how do I draw that as an ion?
Put a 3 and then a bracket.
I need 3 of them because there were 3 chlorines. And now I need to put my bracket. Okay.
Chlorine with all 8 valence electrons.
Chlorine with 8 valence electrons because it's gained electrons to have a full valence shell. And what's
Then
my
it has -1.
-1 because each chlorine only gained 1 valence electron. So 3 chlorines have gained 3 valence electrons between the 3. And then just to double check we've done everything correctly, what do our charges have to add up to?
0.
They have to add up to 0. So do my charges add up to 0?
Yes.
They do because I have my +3 and then I have 3 -1s. So that +3 and then the 3 -1s do in fact add to 0. Any questions on my ionic one? All right, I'm going to go through the next two a little bit quicker. So we have lithium and bromine. With lithium has 1, bromine has 7. So lithium this is ionic because lithium is a metal, and it's going to give or transfer its 1 valence electron to bromine, creating our ionic compound. and we draw an ion form or write an ion form, we have one of each. Bromine gets 8 valence electrons, lithium gets a +1 charge, and bromine has a -1 charge. Last but not least, we have carbon with 4 fluorines. So carbon has 4 valence electrons. Fluorine has 7 valence electrons. It's a covalent compound, which means we are sharing valence electrons between two elements. So we're going to show that the electrons are being shared between these elements. And then we replace that circle with the 2 valence electrons being shared. We replace that with a line or a bond between fluorine and carbon. And then we have to put our extra valence electrons back on fluorine so that every element shows it has 8 valence electrons in total. Any questions on any of those 4 from the formative last Tuesday? All righty, so then the next section, number 2, said table salt is the formula NaCl. Why can't it be the formula Na2Cl? Why can't it be NaCl2 or any other combination? Make sure you reference the octet rule in your explanation. So for this one, I was looking for 3 things to be explained. The number of valence electrons in sodium and chlorine when they're by themselves, when they're just atoms. How many valence electrons they have, how the bond is formed, and then the octet rule. So in this problem, I was looking for those 3 things, or I was looking for you to state that sodium has 1 valence electron and chlorine has chlorine has 7 valence electrons. And because of that octet rule, we know both of them want to have 8. If sodium loses 1 electron, it will have 8 valence electrons. If chlorine gains 1 electron, it has 8 valence electrons. So in order for that to happen, 1 valence electron is lost or transferred from the sodium to the chlorine. So both will have their full 8 valence electrons. They don't want to give away any more or take any more, or else they would be unstable. Are there any questions on that one? All right, so then what I want to do next is I want to talk about your assignment for today. And before we actually do anything with that assignment for today, which is our mixed practice or our combined covalent and ionic formula writing and naming, I want to go down here and I want to talk about ionic and covalent naming. So ionic and covalent naming. So can you guys refresh my memory on ionic or covalent naming? Anything you remember about either of them?
If they have like nitrogen has to end in like IDE.
Perfect. Is that for ionic or covalent or both?
Both.
Both. Second element ending gets changed to IDE, and that's for both. So for both our ionic and covalent, our second element's ending has to change to IDE. If we look at aluminum sulfide, you can see it. iodine monobromide, you can see it. Cobalt 3 nitride, you can see it. Our ending is always going to change to IDE. Anything else we have to remember for either of those two naming?
Sometimes the beginning has like the mono or like D nitride.
All right. So the mono, is that for ionic or covalent?
Covalent.
Covalent. And what do we call those things that we put in front of our elements' names?
Prefixes.
Prefixes. So covalent compounds get prefixes. Exception. Who remembers the exception?
Non-metal.
All our covalent compounds are nonmetals. So what is exception for our prefix? What's the one time there isn't a prefix on one of our elements?
When it's a metal.
Nope, metals are ionic.
When it's only one.
When there's only one, and if there's only one, for which one? Is it the first one or the second one?
The first one.
Perfect. The exception is if there is one of the first nonmetal. So if there's one of that first nonmetal, it does not get a prefix. Any other rules we got to remember?
No.
What's that? What is
Roman
that?
numerals.
That's how many valence electrons.
And when do we use those Roman numerals, or how many valence electrons we have? When do we have to worry about that?
When there's like a metal.
When they're metal, okay? So metals worry about charge. Okay, specifically or especially, what kind of metals?
Transition metal.
Transition metals, perfect. Because what do they get? If it's a transition metals, what might we have to put on them?
Roman numerals.
The Roman numerals, perfect. And where do we look if we have to figure out Roman numerals?
The Roman numeral chart.
On the ion chart. Perfect. Ion sheet. That Roman numeral chart. All right. And then I was told the prefixes. So if we wanted to rewrite them down, we have mono, di, tri, tetra. Ooh, should be penta, hexa, hepta, octa, nona, and deca. Is there anything else you have to worry about, or is that everything? I think that is everything that I was thinking you might need to watch out for. If you guys have any questions and you want to go through any of these, let me know. Otherwise, have a wonderful rest of